this rain effects we're going to do different from the last project, which is snow. In the snow we created everything in CG, as in like we used the help of Megascan and we created the scene, right? So now we're going to do image based. So this is the image we're going to work on it. Just an image that I got from unsplash.com. You can get anything of your choice. So basically what I'm going to do is I'm going to make a rainfall over here, but it's going to be a very basic, that there won't be any collision over here or any of the pipes, and there won't be any wet map as well. But all there will be is a rain, and this collision will be there. So that's why I used a wet image, so that you get there's already wet, right? So we can fake our rain easily. I have my project set up, all set. I'm continuing with the same project 3. So you can continue by going to the file and set the project and get the project that you want and accept it. So that's going to be a project, continuation of project, something like that. Okay, so we're gonna bring a camera first, right? So first we are trying to match the picture, like match the ground. Right now Houdini doesn't know what is the ground for this image, isn't it? So we need to do that first. So this is a simple technique. Okay, so go to the camera, and in the view you can find down here enable background image. So get that image. So when you have it, you can see it by going to this camera 3. So camera 3, you can see that, yeah, right? So now what you have to do is you have to match the ground. So in our thing, so this is the ground, right? The grid is the ground origin, isn't it? So we need to match the camera and the grid. All right, so how you can do that is by manually, is by like locking the camera and you roll it. You can see, I think you can see here what I'm doing in the grid. This ground in the picture, what you see in the ground has to match with this grid, right? So this is how you can do. And one tip will be get a grid, right? Just to see. So now you have a grid. Okay, so now you can adjust the grid, and you go inside the grid and you change the size to very small so that it fits just like your ground. And yeah, something like this, right? Size, I'm just sizing it, and I'm still in the camera mode. And now I will try to match like this. Okay, so you have to manually do it. It's pretty tricky to get exactly. The grid line can be hardly seen, so get a grid polygon and try to match it. And once you have it, then if you want to keep it, or otherwise just leave it. Basically we are matching it. So if you want to see if the height is really correct, then you need to go get a human, or like you can get there's this template body. So I believe this is good, like, isn't it? The height is good, but you can see it. So I don't think that is correct. Like, that is wrong. So you have to play around with the camera settings and to level it perfectly, match it. Give me a second, I'll match the scene and I'll get back to you. I'm back. I got my test geometry all set up. So I have another test geometry just to see if it's working. So I brought this crack guy. Now you can see it is looking just perfect, the height that I'm looking for. And if you move this guy back, I think it's perfect, right? The far distance is correct, I believe. Give a test geometry with the Tommy, then you can bring and you can play around if this guy fits correctly. So basically that's how you can see if your camera setting is matched with your ground level or the grid line, right? So I'm gonna delete both of these. I'm just keeping the crack and the ground leveling. So in the ground level, you can see what I did is just sized up and rows and column I increase the rows and column. That's it. First level is done, which is matching the camera with the plate. So we will enable all of this. Now you can see here is our camera. So whatever we are giving here, going to see through the camera, right? The camera is set up, and whatever we are putting here, it's going to be there, and the level is perfect. So I will start the rain effects. Okay, so right, so let that be. So whatever we going to do, it should be here, right? So we're going to create a grid usual. I'll bring the tools that we used in the geometry level for snow effects in here. So this was the snow techniques that we used. We moved on top, and then we used attribute attribute noise to get points jiggled. I'll increase the grid point, and that's how we drive our scatter point, isn't it? Snow. But this time we're going to do differently. How it's going to be is, in the snow we gave the force or velocity in the dynamic level, in the pop level, by using pop wind and stuff. But here in this rain, it's up to you. You can use the same technique, but I want to show you another technique that we can also bring the velocity in the geometry level, and we can drive that. The reason why we have three options, a force or velocity in the geometry level and in the dynamic and in the pop source, is that when you have a complex idea, complex simulations, like you have 5 different pop sim is happening, and all the 5 has a different collision, and each collision has a different behavior. So then it's going to be really hard to do everything in the pop source, I mean in the pop dynamic level. So it's better to bring, when complex effects you are looking forward, then the geometry level attribute will help you a lot. Basically this effect you can do with just grid and go to the pop, but I just want to show you different techniques, why we use it in the geometry level and the dynamic level. So that's what I want to show. Here is our grid, and we use a transform node. It's not that much going on, right? So we can minimize it slowly, yes, and let's look here. Good. And we bring it on top really high, because it's rain and it has to cover this area. Okay, and we'll also expand a little bit only. In your camera view you can see that's there, and if you want to see right through, then see, yeah, you see it's right there. So don't worry about that. We are good to go with this size. Okay, so I'll put it small. So I'll put it only this much. Okay, and the next one, what we want to do is, in this method we are planning to do to give the force or velocity in the geometry level, right? So we need a velocity to drive the particles downwards. So as a default, the normal facing is up here, because you can see it down here, the normal is not facing. If you want to see that, then put the display. The vertices of the normal is facing up as a default, and there is no normal also. It's just a default. When polygon is creating, you need a normal, so that's why you have the vertices upwards. But we want the rain to go down, right, not up, isn't it? So we want all the point that we gonna generate to face down, isn't it? No, this is not called normal. You can change what normal you want. Right now as a default it is vertices. Now if you middle mouse, you can see vertices normal, but you can put it into point. But you see it is again facing upwards, right? So we want to do it downwards. How do we get that? There is no option in here like to say that, -1 go down. No. So that way, this is node in the attribute called attribute expression. So in this, they have a really lot of connection point input, like so many sub network. But for now, you just worried about one sub network, okay, and you don't double click it, no double clicking, but just clicking it, and you can see here, okay, what attribute you are looking for. You can see the groups and stuff, though ignore all of this. Attribute class is point, of course, that's what we are after. Point is what we are after. And in the attribute you can say that, okay, whatever attribute you want to have. So I want normal. Okay, so right now it is self. Like if I click here, it is self point is happening. So what we want is, if you click here, you have bunch of preset options in that you can definitely, like, you know, you can go for random, then it's going to be having random, but still it is going upwards. Of course you can give a negative value here and it goes here. That's a good techniques, but we don't want, you know, random. We want like what we want. So right, so you have different options basically, and what we want is constant value, so that we can give the value whatever we want. So then I said -1, then voila, you have the normal facing down. Why normal? That's a good question. Like, why normal, when you can just bring a node called point velocity, right? So point velocity that I explained, like in the like previously, in here you can actually give a velocity, isn't it? It is right, it is not a bad idea. You can just directly connect the point velocity and give the velocity here, no problem. But we are looking for noise. We are looking for noise kind of pattern. Not straight, but noise, as in random. The rain is always a random. Rain never just goes straight down, isn't it? So what we're going to do is, okay, right now we have a normal facing downwards, and we know that if we use attribute warp, we can manipulate anything, basically anything, normal to anything. So what we can do is, we will try to manipulate the normal, and once we have different or the direction of our like, then we will plug that normal to velocity and drive that velocity as our velocity, isn't it? So to do that, we bring attribute warp, and as you guys know, turbulent noise is the easiest one. Click here and you click here, but then it is all going upwards. So that is because turbulent noise has a value itself. You see, turbulent noise have these kind of value. So as you go, it is also changing, isn't it? So, but what we want is, we already have a normal value in here, okay, in here, -1. So we can multiply that. Okay, so I'll multiply that, the normal which we have already, which is, you know, 0 and -1 have already, and that's going to multiply with whatever value this has. So if like you saw here, it has a value of, you know, 0.15, right? So that's going to multiply with this value and get a different result. Okay, so that's what we're going to do. Okay, and one more thing, if you notice, in the turbulent noise, you see x, y, z all are same. In the attribute warp class, you must be knowing that it's because it is in the 1D. So if you change it to 3D, you will have 3 different data for all the axes, isn't it? So now you have that, and now all you do is just plug in and put that value. So now you go here, you can see x and z is 0. That's because this doesn't have any value, so it is multiplying with that and getting you results 0. Yeah, that's because it is 0 0. That's why it doesn't give you any different shape. So we going to give an extra in all the axes, maybe 1.5. Okay, so now you come here, you have in the x and y, you have a different value. Yes, so it is working. I'll increase the grid, okay, so that it's easy to see. The next is how you play around. You can promote all of this, you can add if you want, right? But for me this is enough. So you have that, and you play around with the amplitude, maybe the roughness, how you want it. Okay, so it looks good. I think for rain it is not only straight, but also you can control that x-axis from here, z-axis I think. Yeah, here you can get that randomness from here, because that's going to multiply. Basically this value is multiplying with this value and giving that as our normal. So I believe this is fine, and what I'm going to do is I'm going to say that our motivation, isn't it? If you plug in the normal, it doesn't matter, but our goal is to get velocity. So whatever you see this normal will be our velocity direction. So let's begin our pop. I brought this pop network. I did not change anything. Default, just the default. And when I click and when I press play, you see I already have what I'm looking for, but it is to that side, isn't it? So I'm going to change this value to 0.1 only. Okay, so now I have, if you're plugging directly here, just imagine, okay, so just imagine you're plugging directly here and you have a gravity. See the result, what you are getting. Okay, so I put a gravity and I'd have no attribute coming from geometry level. All I have is in the force from pop level. So now you see it is all straight. What a waste, isn't it? So look at ours, and in ours we don't need a gravity because we are giving a gravity by our own idea. So see, it's looking good, and at least not really good, but the shapes are different, isn't it? The shapes are different. Some are very speed, some are very slow. That's what we want. Okay, so the next part will be all similar to the snow setup. It's like I am getting the scatter on surface. Birth depends upon what you want. Birth is good. Attribute, it is bringing attribute. C star means it is getting my velocity as well, and you can give more, multiply. So whatever the I'll show you right now, show with the proof. So I want to see my velocity. Okay, hide all and keep only the velocity. So if I give 10, then you're going to see here it's going to be 1.4 or something. So see 1.4. So basically it is multiplying whatever the velocity we have here means in the geo level. Okay, so you can get a speed from there, inherit velocity, but that's depends to yours. I think I'm happy with what I have, but when you see here it is going too much on that side, so I will control that part. Okay, so I don't want that much to go. So yeah, okay, maybe this is good, and I'll go to the camera and play again. Yes, I'm getting it. This is called near clipping problem. When you have near clipping problem, like you can see, or if everything is cut off, then space F, then it focus, so that's how you can fix your near clipping problem, right? So you have the camera here and the rain. So next one, what we're gonna do is, I believe we need pop wind. From the previous experience, you might know that we need pop property for giving bounce, mass and friction. Rain have a mass, like some drop will be very strong, right? So has a mass, and bounce, we haven't put the collision, so we'll put it, and the friction. Okay, so of course we will be needing a pop drag. We need a collision geometry. Since we know we have our ground is the grid, then we can just bring the ground, then everything is settled. You don't need to bring a static object. If you have any static objects, like in this one, if you have any of these, you have to create all then only it collides. But in our case, we match the grid line to our ground, so the ground plane will be easier fix. So now you can see, 1 minute, I will ignore all of this force and play. Then you can see it is touching the ground everywhere. So we have that. So in the pop source, I put some wind velocity in the so that's because you can see here when I play, it is stopping here because of the wind. When I add the swirl and amplitude, you can see it is swirl and amplitude is taking the velocity down. So of course you can go here and give a big value, and that is one good fix, but then still it's happening, affecting the initial point, and then the wind is taking care of it. So if we change that, then nothing's gonna happen. So keep the inherent velocity 10, and in the wind, if we give a force downwards, then it will fix. Okay, so now you have that. So okay, so that's the only thing I did in the wind. So the settings are this, and in here what I changed is I gave the value 0.05. okay, just to show you, I was playing around and I found that value is good. It will be different with the different image that you're playing. Okay, it's dependent upon what you're after, but this setup will be basically it to carry out your project. Play around with these settings, then you'll be good to go. And the next one I want to show you is the property I added. So I'll put that into the default. So in rain, if you notice, the mass, bounce, friction are random, so we can give that random. Like in the snow, I've discussed this one, so we can copy, paste, and give the name. Mass is correct, bounce, okay, spelling has to be correct. If you have any doubt with the spelling or how do I know, that's because if you hover over, you can see the parameter friction, the parameter bounce. That's how I know parameter is this way. And to clarify that, if I press Control and enter, it's going to give me an error. That's because the spelling is wrong, and it is trying to see wherever this spelling was, but it couldn't find any. But now it is perfect. So perfect, BFMR small letter. And yeah, you can play with the value, how mass you want, how bounce you want, and how friction you want, based on that. I'll be playing around, but just want to discuss what it is. And the pop drag doesn't do much with our settings. When I hit play, you can see it is dragging entire points once it reach. Okay, so that we don't need it. So I'm going to delete that, because since it is not helping us, why would we need to keep them? And next I want to bring pop collision. Why pop collision behavior? I'll tell you. I'll hit a play. Right now I'm not doing anything. It is none. The response is none. You can see it is bouncing back this much. You see, it is bouncing back a lot. So what we need, the rain doesn't do that. What rain does is, when it hits the ground, it's going to give a tiny splash, very tiny splash. I believe you have noticed that. And there will be a ripple, but we won't be covering the ripple. Pop is what we are focused, so we try to get that splash. So in order to get the splash, what we need is, in the collision behavior, you need to say that died. Like, of course there is no bounce back, but we know that there is this pop tool called replicate somewhere here. Yeah, replicate. So replicate can carry out the rest, isn't it? So we're gonna say die. Whenever it hits it, let it die, and whatever die, I want to preserve the group under the name splash. Okay, so now we have splash group where all the die particles exist. First you delete this ground, so we can do by getting this name, coming back in the object, instead of star, say that pop object. So it's going to give you only the pop object. Now you can see here, of course there is no, because when you click here you can see Splash and the source group have there, but Splash doesn't have anything in their group. So that's because right, it is dying, so nothing, right? But so we're gonna bring that, since we have that group, like it is dying, but we can bring that. So it's by pop stream, we are getting a new line. So this is the main one, and here we are taking the next one. We can actually do it here, no problems. Like you can bring pop replicate here and say that you need the group Splash and put spear and very less scale. Birth will be maybe 10. Okay, and that should do the work. You can see it is bouncing back a lot. You see the red replicate is the red one, it is bouncing back a lot. That's actually because in the pop property our bounce scale is big. In fact, so this is trying to multiply, the value from here is trying to multiply with this one. So what we can do is we can put here maybe 0.1, so that in total this will be the bounce value, and this is going to multiply. So when you play right now, you can get small bounce. Still you can see it is going towards up. We can give a gravity so that it just falls down back. So we give a gravity, now it will be smooth and easy. Okay, so we need a little bit of in the y-axis we need some velocity. So I'll put, maybe let's try 1, and then we will see in the replicate. So what we are doing is changing the value of replicate. Okay, the red one, not the white one. White one is kind of over. So you see right now I get a good bouncing. I think that's good enough, right? But you can play around if you want. You can also do the same this way, like you keep your source group, it's like first you can't get that unless you connect it into the merge group. So now you will have that Splash, you get the Splash, and instead of bringing in here, you said the same. Okay, now it is more organized. So you get the same only, everything will be same. If you don't believe it, I'll just give 3 value. You can see a bigger jump in the bounce, you see bigger one. Okay, so you can play accordingly. And the shape, I'll put size, instead of that I'll put here the uniform scale. It's both the same. If you keep it 0.1 in everything and 0.1 in here, is the same. This is like scaling, and this is like kind of p scaling or uniform scaling. It's good. Now I need some tweak in that session also. After that it's over. So I'll be mostly playing with this value, and I'll come back with the right value. After playing with the value, I got this as my result. You can see extra pop kill has been added. Okay, so I'll just show you what all changes I did. In the pop source, I increased it to 30,000. Nothing else. Life expectancy and everything is same, right? You can pause and see the value. And the pop wind, this is the value that I've gave. Velocity and swirl, I don't need much of swirl because the place is closed, and I don't think in a closed place you get a lot of swirl coming. It will be mostly straight, right? And the pop property, I changed a value. The bounce, I put 0.1, and that is going to multiply with the value of 0.01 to 1. Okay, so this is the value that I gave. You can pause and have a look. And in the collusion behavior, nothing changed. Group name Splash, preserved it and die. And in the pop stream, I brought the Splash. And in the pop replicate, I changed a little bit. So birth, I increased it. The constant birth I increased to 100 per second. okay, and life expectancy 0.3, because when the rain falls and hits the ground and splash and just die, right? So my life expectancy is very less. And the next one I gave is shape uniform, didn't change much, same thing. And noise, I did not give any noise. In attribute, I changed one thing, so I can keep variance 0.1111. And what I did in the velocity, that's what you have to know. Without this expression, you can keep it too. You have a beautiful splash, but I wanted based on mass. So random mass. So this is just really simple. It's like I'm taking this attribute mass, which is from here, this one 0.621 value. So taking these values, which is like multiplying with this one, so which is 1, taking this value and randomly generating mass for each points, and I'm multiplying by 2. That's because it wasn't giving it much a bounce. So this velocity is basically for bounce. That's what I'm doing it for. So you can see here, so without any multiply, you can see the value is very, yeah, see the bounce is very less. And if I keep it like, so I wanted to multiply it, so if I keep it 5, you can see that what it's doing, right? So see, bigger. So I have the velocity, initial velocity up to 5, so which is what my bounce is. So I keep it 2, which is fairly reasonable. Well, without this random mass, you can see what it's going to give you. So I'll put this value. Okay, so you can see it's a straight, you can see straight, there's no, I don't see any difference, it's all straight. So that's why I used this random just to make our randomized velocity in the y-axis when splashing, or when we are doing the splash group. Okay. And the other thing I've changed is, you can see a big pillar in the middle, so that is nothing but pop kill. And I did not do enable here, I enabled the bounding box and manually. So everything, this value is manual, so manually I went to the camera and I played it. Okay, so I played it, and then I paused somewhere there is rain falls, and then I went pop, and see, you can see here I was adjusting manually, like wherever you want you can keep it. Okay, so it was manual, all the size. I kept it tall because I don't want any rain to generate in this area. So the reason why is simple. You can see this one, and here there is no wet floor. So when if we don't have this pop kill, and it's gonna come, the rain's gonna come over here and it won't look real. It's like we are faking it, right? So we need to fake really good. The other thing I did is I did change the grid size, okay, and the position. So I adjusted here, see, I adjusted right at the corner. In the beginning I did not adjust as perfectly, so I did go into the grid parameter, and this is what I did. Okay, so I even did that. Okay, so other than that, everything is cool. So we're gonna separate it. So we take pop replicate. Okay, so now we have that pop replicate, and then duplicate it and says non-selected. So we have both now, the replicated ones and the rain. Okay, we have that. So don't worry if it says error. That's because in the beginning there is no, like, they can't find any points, that's why. But as you generate, then everything is cool. Okay, same with the splash. in the beginning it's gonna do this, but no worries, it will be there. So I'll make the total frame to 100. I'll also do the pre-roll. 35 is good, minus 35. Okay, so I have the splash, right? I have the splash, just the splash here. So the next one I want to do is I wanted to give all this point, whatever the splash is, all this point a shape or a geometry. So if you notice in the rain, you can see there's a tiny of maybe it's like a circle or circle with a little of shape, right? So you can take anything, you can replace that to this point to any shape. If you directly render this out with the points, then you know, right, you can't apply material on that. What we're going to do is we're going to bring the glass material. Okay, I already drag and drop it, just drag and drop it, that's it. Okay, so I already have a glass material, it is in the library, so nothing to worry about that. Okay, so I will need to apply a glass material, so it need to have a geometry, right? So we know that copy stamp can do that job to replace these particles to geometry. So you can bring a sphere, you can make shape using this mountain, but I'm doing this in a different way. So how I'm doing is I'm taking to this poly mesh and giving a really low value like 5 by 5 or anything. That's because I want very less polygons so that it runs fast, but it's up to you. If you want to do a really good shape, you can give a higher resolution and change to mountain. But since the splash is very small, like I know it's going to be, my camera is somewhere here and the splash will be very tiny, right? So there's no point of keeping it big and giving a lot of details. It's a waste. Connect that to copy node, copy stamp, right? And I wanted to plug, but before that, right, these particles, what you see, these particles has a p scale as a default, and we need to change that. So attribute create and give a p scale without, I'm doing that without connecting, because when I connect, I know it's going to take some time to load. So before it take to load, because as a default the size is big, and when you connect that directly to the points, it's going to be a really big sphere that you're going to get. All right, so but I don't want to do that. I don't want to waste time on that. So I'll give a value very small, p scale, point, float, and the value. So I'll keep somewhat like 0.035 or something, very small. So connect it, and it replaces so fast. See, you have that splash with all of this, and I don't want to give any shapes or any orientation to the splash because it's going to be it's very tiny. So I'll keep it this way for this one. Okay, and let's take the rain. So rain, I want to approach differently. So in the rain, I'll do the same sphere and the copy. So I'll bring sphere, but for this sphere, I'm trying to give a water shape that you guys know. It's very simply I'm doing it. It's like I'm gonna edit, I'm gonna actually plug this point up, then I get that water shape, isn't it? So I'm using edit node. You can shape it in your own way, and you always know that like this point is always be 0, whatever in the top. So if you go anything, it's going to be the 0, that's going to be the 0. So since you know that, then you can just type 0 and make it as, now it looks like water drops. So I'm going to connect that with the copy stamp, and here I would like to do what I would like. I'll just drag and drop this one. I'll try copying it. Okay, so you can see here everything is replaced, everything is very tiny replaced, and you can see that is not a cut, that is camera far clip problem. Okay, so you see it is facing this side, so I want to change the orientation, and p scale is good, but even I will change the p scale. So we can do in the attribute create, like we can create an attribute called orient and do that, but this time I want to do differently. I'm going to delete this one. So I'm getting away from the copy because it's going to take some time to load. So I'm going to get attribute warp. So in the warp, I'm going to create orient and p-scale inside this. I'm going to approach differently in this one, just to show you, just to give you some flexibilities to do, differently in a different project based on what your idea is. Okay, so first thing what we need is our orientation was facing this side, so we need to face it down, right? So instead what you can think is we can take the velocity, how the velocity is going downwards, isn't it? The rains are going downwards, right? So like we can take that as our orientation, isn't it? Like, so we can use velocity. So velocity is the great tool to get in this, only in this situation, okay, in this situation, because I told you it is going down. So we can take velocity and orient. Since you know orient is, why can't we take rotation, or why can't we take any other orient or any other attributes? It's because we need that we are playing with the direction in this one. Okay, so the direction of the point is the problem. Direction is facing this side, we want to face this side, so orientation is the best approach. Just like p-scale and scale. Scale is for, squeezy or stretchy, when p-scale is like uniformly scaling. So orient is good when compared to rot. Rot means rotation. You guys know that orientation is a 4 vector or 4 float, and velocity is 3. You can come here and see what is velocity. So you see xyz, so it is a 3 vector, and the orientation is 4 vector. So we need to change the velocity 3 vector to 4, so that will be vector and vector to 4. So see, it is vector, so vector hvac is I don't know, that's how they name it, I guess. So basically it is, right now it is vector, so it has 3 inside and a 1 value. So 1 value, you can actually, this value is time. Okay, so this is time, but we are not taking from anything from the time. We actually wanted to just convert this 3 vector to 4. That's it. We know that we want the output has an orient, but there is no orient, so we need to bring our orient, bind export orient, and when we plug it, boom, it is not there because I have to on it. Boom. So you see the value is same, isn't it? The O value and B value is same. X, Y, Z, X, Y, Z. It's the same. So whatever the velocity is, that's going to be how our geometry's orient or direction, where it's going to face. And this is 0 because we haven't plugged anything, and it is time, and we don't have any time related in the velocity, so let it be 0. And now if you just drag and drop this p-scale value and click it, see, it is facing downwards. Everything is facing downwards according to the velocity. Everything has a different direction based on the velocity, right? But then I think, okay, then I'm like, okay, we have mass as well, right? We have here mass, isn't it? So we have mass. Then what do you think? Based on the mass, we can also keep the point scale. Okay, so right now p-scale is, everything is this value 0.0035. Of course you can get an attribute randomize and get a random value. This time I want to play differently. I want to say that, okay, whichever has more mass, make that size big, and whichever has small mass, for example, if mass is 10, then the size is 5, and if the mass is 1, the size is 0.5 or something, right? So I'm deleting, I know that I'm deleting the p-scale, and to do that what we can do is fairly simple. It's like we bring bind, because there is no mass attribute, so we have to bring a mass attribute. So I have a mass attribute which is coming from here. You see, in the in the dynamic level we gave a mask, so that is here. So I'm bringing that, in a way it is look like here. So I'm bringing mask from the geometry, okay, and I'm exporting that by an export. That both are different, by the way, okay. So it looks like both are same, but see export when input is connected, never, okay. So I'm exporting that. Even here there is no p scale. We need to bring that two attributes, that is mass and p scale, since it is not in the list, okay. So I say p scale, and when I plug that in, nothing is happening. But I just want to show you in the spreadsheet, if both are equal. So I'll bring just mass and p scale. See, the mass and p scale is same right now, okay. So we transferred, so whatever the mass, if mass is 1, the p scale is 1, okay. Or if the mass is 6, p scale is 6. But you know that, like in this one experience, you know that if I keep it p scale 1, so which is the mass 9, right? So if I keep the p scale 1, the size of that particle is huge, right? So how will we achieve that one? It will be this big, and the lower value is 0.6, so that will be half of this. So we can't keep this as our p scale to the rain, right? This is so big. So how can you do, how can you make, like, whatever the big value of mass is, I want that p scale also big, but it need a limit, okay. Like it shouldn't be, so I want to say if it is 9, then p scale is 009, okay. So somewhat like that. So of course you can do that by divide. If you put divide by constant and say that 100, you can get that, okay. You have that. So now it is, the value is 9. So this is a good method. It's like you are actually dividing and getting. So it's like whatever the mass 9, p scale will be 9, and whatever the 6, p scale will be 6. But this is also good method, but I want to show you using fit range, okay. So we will type, so we, before putting the fit range, I will see what's the minimum and maximum. So minimum is 0.6 and maximum is 9, okay. So fit range, minimum is 6 and maximum is 9, so I keep it 1 and I'll keep it 5, okay. Now it is being modified. It's like whatever this value 6 and 9, it is now, we can control, like we can say it has to be it has to be in between 003 and 0.005. So it's like the value of this one is now converted between 3 and 5. 0.5 and 1 is converted to 003 and 005. So you see 9 is 5 maximum value, and 6 is 3 minimum value, okay. So you have that. Now if you go and connect, yeah, you see the magic. You see everything has shape, and based on the mass, you can see some are very small, some are big, okay. Now of course you can control, to get a further control, what we can do is middle mouse click and promote parameter, middle mouse click and promote parameter, so that you don't have to get inside and outside. All you can do is, it is here, minimum and maximum, so you can control over here. So it's like you can keep it 1, you see 1, okay. I'm undoing it because I'm not looking for that value, and then we will merge both, okay. So we have both. So after the merge, you can put a file cache and try to save your cache into your disk so that it runs faster. So better get a file cache and read from that file node, right? I'm gonna get my file cache done after explaining materials and rendering. Awesome, isn't it? And then we will apply material. So I have already applied material here. So this one, glass, copy, and you can, of course, you can bring a material here, and you can do that. I'm doing this time differently, so I'm pasting here. Okay, so now if I go to the shader view, so you see the shader has been applied. You see it is all glass, and then output mantra, and in the mantra all I'm doing is what we need is motion blur, right? So I put the motion blur on because it is falling, so motion blur will be looking good. So just like in the snow, we'll do that. But you can see here motion blur need velocity, right? So if you middle mouse click it, there is no velocity coming. Okay, so in the last snow also I mentioned you there, if there is a velocity, then the motion blur will work. So if right now there is no motion velocity coming, but here it's coming, here is coming, and here it's coming. So you in the previous class you know that in the copy node there is this attribute that you can transfer. Now it will transfer everything. Okay, see we have velocity, and I'll do the same for this. Go to copy stamp attribute, use the template, then CV, everything is transferred. So we have everything, and there is velocity as well. Don't worry about mismatch because in the one of the side we have orient. So this one orient attribute, and this doesn't have an orient attribute. That is fine in our case. So mismatch is okay, but if that bothers you, then what you can do is you bring a null here and you bring a null here, and bring both the geometry separately outside here, so it will fix that. But I'm doing it inside only, right? I have an environment, and I've downloaded an HDRI from the HDRI Heaven, so you can see this one. So this is the HDRI I've taken. This is the HDRI I've taken, some rural it's called. So because my mood to this picture matches with that cloud, so I use that. And of course I also changed the camera settings because this picture has a resolution of this one. See, pixel is 7005, so it is almost 6K or something. It's really big. In the Houdini, what I did is like I brought that value. Okay, I brought that value same and divided by a huge value so that I get this value. Like why I divided is because that's the easiest way, right? Easiest way to get like instead of you dividing it by using calculator, like why spending so much time, you just divide from here. Why 6.5? It's just like that. You keep it same, then you have that anything. So now the shape, now this resolution is 1115 and 744, which is almost HD. Okay, not full HD, half HD, so which is good. Okay, but you can play around. The advice for this one is when you're taking a picture, try to get HD picture so that you won't need to do all of this, because as a default you can see in the camera settings, the resolution will be 1280 and 720. So get similar to that picture, and then you don't have to do these changes. And now let's do the render. So here is the render I got. See, the size is 1201 and 801 minimum one. So see here 12001 and 8001, 6.5 divided. So I got that same. And you see the rain, it's good, it's getting good. Like I also have this floor touching, and this part is there is no splash coming, so I think we are good. And And what you can do is you can play around with the settings inside your pop. Get so in my replicate, I gave some value on the velocity, 0.1 and 0.1 x and z, just like that. But what you have to do is you have to play around with this value and the shape value. This is basically how what's the velocity the splash has to get, okay, and the variance, of that velocity, okay. And in the shape, how do you want that replicate to fall, like a spear or like anything you have it. And so my splash looks like spear, so I want spear kind of replicate, and with the uniform of this one, okay. And I changed the birth rate to 300. So that's the one thing you need to play around for quite a long time. And collision behavior, you don't have to play around. And the property also, you can play around with this value, on this value. And pop wind, you can speed up your wind speed how you want, and get a swirl, how do you want the swirl. You can also bring another wind for a tiny thing, but in this picture, since it is closed, I don't need a lot of wind, because there's no place for wind. In reality, there's no place for wind to come here, okay. So that's the only part you need to take care of. And the p scale, play with the value. It need not to be the same as mine in your case, so it changed the value. And even here you change the minimum, and this is p scale value, you can change that. Orient will be same as what I just did. Orient will be same, so nothing to worry about that. And the shape of the spear based on your approach, like how you want the look. My advice is don't play around too much with the spear and this one, because anyway we're going to put motion blur, right? So there's no point for seeing that. And you can control this motion blur in two ways. So one is, if in case that doesn't work for you, one is in the camera, you can go to the sampling and play with the shutter time, not like 1 or 2 value, give it 0.1, and this will change the motion blur captured value. And next one you can play around is go to the glass and get the roughness. So right now the roughness is 0. As a default, glass has a 0 rough. So you can play around. I can just show you. If I put this value, see here, I changed the value of the roughness of the glass to 1, and you can see here I gave the name, so you can see here, so this is 0.75. when I put the value 0.75, this is what we get. And if this is 0, so 0 has more color. And then the roughness, when I kept the roughness into 7, then it is more reflective, like you can see through. And if I put very much roughness, then it is very light. So you can play around to get depending on your shot. So right now I did not render this part, I only rendered this part. That's what you see. So from the rain and snow project, I hope you probably learned how to get asset from Megascan, how to play with the inbuilt tools like replicate, pop collision behavior, pop property, etc, etc. And most importantly, you have now a hand on how to bring force or velocity from both dynamic and geometry level. In the snow project, we use dynamic level for getting the velocity by the nodes like pop wind and pop force and stuff. But in this rain, we used velocity in the geometry level, and then we brought that to the dynamic level, and in the dynamic level we added little more velocity to refine the effects. So rain effects, we did a mixed use of velocity from both dynamic and geometry level. And on top of that, you learn how to bring attributes in the parameter channel, and also learn how to bring attributes in the warp level by your own. So hope you enjoyed this project, both snow and rain. In my side, what I want you to do to get hang on tweaking, otherwise playing with the values. You have to play around with the values like higher and lower and try seeing the change, like whatever changes you see, just notice that, because more likely you're going to get crash. That's the only thing you can get, and get out of the fear of tweaking. Don't play with the value that I've mentioned. Play with your own value, get it crash, no problem, just save before tweaking any values, and then you are good to go. Get out of the box of fear of tweaking, and fear of getting not getting result, because not getting result is the best way to learn, because when you get into problem you will learn more. And when you are copying my values just like that, then you are not learning, actually getting the result, right? So try not to get result, also try to get problems, so that you can get out of that fear, start making your own effects. So that's all I want to say.